Now the mechanical window has been opened out where we'll be applying out the boundary conditions and the force on the simply supported beam. So for the application of this fixity, that is boundary conditions, and the point load which is acting at 2.5 meter, that is at center, I'll be right clicking on this static structural option and I'll be inserting out the fixed support. And just close out these tabs. Okay, I'll be just choosing out the vertex option at the top, and for fixing out the nodes, I'll be just clicking on this apply selection, which will just create out the first fixity. Again, I'll be going back on clicking on outline for inserting out the second fixed support, and I'll be choosing out the second endpoint where again I'll be fixing out the support. Okay, so if you just click on the outline, you are having this two fixed support A and B, which creates out the simply supported beam. Now at the center, uh, we'll be applying out a point load. That is, I'll be just right clicking on the static structural, and by insert option, I'll be clicking on the force option where I'll be choosing out the point where I'm going to apply out the particular point load. So I'll just select out the point load where I'm going to apply out the force. The magnitude of this force is 8 kilonewton. Okay, so I'll be just applying out that force first. Okay, which will just create out the force. I will just bring out this particular beam in front view, and I'll just click on the cross section icon at the top, which will just give out the generalized idea regarding the fixity and the point load which will be acting on this simply supported beam. Okay, so just clicking on the force details, I'll be just applying out the force in minus y direction. If you just look out for the xy axis, the force will be acting at the center, and the magnitude of this force is 8 kilonewton, which will be acting out in downward direction. So we have to apply out the force in downward direction, that will be in minus y direction. So I'll be choosing out components first of all, where we'll be getting out this x, y, and z components, in which I'll be choosing out with this y component where I'll be entering out the value of the force in downward direction. Okay, that is 8 kilonewton. It will become out in Newton. It will be minus 8,000 Newton. Okay, so which will just create out this particular force at the mid at 2.5 meter of value. It is 8 kilonewton. So I'll be again back clicking on the outline, and I'll be just moving towards the solution part. So I'll be clicking on solution here, right clicking on solution, where I'll be inserting out the total deformation that will be induced out in this beam, and I'll be also inserting out the beam tool for this simply supported beam. Once I just complete out with this, okay, I'll just right click again on the solution, and I'll just click on solve command. So it will take out just time. First of all, it will just mesh out this beam. You can just check out at the bottom, it shows out the 100% meshing has been done out. It takes out some time for doing out the mathematical calculation for this simply supported beam, which carries out a point load at a center. Total span of this particular beam is 5 meter, and where the point load it is acting at 2.5 meter, that is at center, and the magnitude of this particular point load it is 8 kilonewton, which is acting out downward. Okay, so it takes out some time for doing out the mathematical modeling part in this Ansys Workbench 2020 version. Okay, you can also download out the student version from the Ansys official side. Okay, you can just simply download out this 2020, that is R2 version for this Ansys Workbench, and you can just install out on your laptop or in your desktop. Okay, now it is 85% for solving out this mathematical model. Once it becomes out 100%, will be ready for giving out the results. So now it is ready. You can just check out on that downward icon. It is ready. So once I just simply click on the total deformation uh, command, it will just show out the total deformation that will be induced out in this simply supported beam, which is maximum at the center where the point load has been acting out. You can just check out from this color pattern. Uh, The deformation, it is total deformation in mm. At the supports it is 0. The blue color indicates out there is 0, or it is minimum deformation. But at the center where the point load of 8 kilonewton where is acted out, the deformation that we are getting out in mm, it is 0.012575 mm at the center. Okay, now again after checking out the deformation here, again we'll be discussing out, or here I'll be just inserting out one more command to check out the shear force and bending moment diagram. So from this beam results, by right clicking on this solution, okay, so by just right clicking on the solution, I'll be inserting out from the beam results, I'll be inserting out the shear moment diagram here. Okay, once I complete out the shear moment diagram, because we are also going to check out the shear force and the bending moment that will be induced out in this diagram. Okay, that will be plotted out in this Ansys Workbench 2020 version. So for this part, to plot out this SFD and BMD, I will simply right click on this model at top, and I will insert out the construct geometry option where I'll be defining out the path. So I have done out, I have right click on the model option where I have inserted construction geometry option through which I have inserted out the path. Okay, now to define out this particular path, okay, I'll just go back to the line mode. To define out this entire path, we have to go with edges. So for that purpose, to define that path type, I will select out the edge option. Okay, once I select out the edge option, we have to select out both the edges. Okay, so for selecting out the edge, I'll be just right clicking on the edge option on the toolbar, and I'll be selecting out this two edges, edge number 1, and this is my edge number 2. Once I select out that, okay, so I'll be just applying out this path option. Okay, so which completes out my path. Okay, so just by clicking on the outline again, okay, I'll be just right clicking on the total shear moment diagram, and I'll be just going with the details where I'll be defining out the path for this particular shear moment. Okay, which will just select out the path for this drawing out the total shear moment diagram for this simply supported beam which carries out a point load at the center. Once I complete out this, I'll be just right clicking on this total shear moment diagram, and I will just evaluate all results. So it will take out some time for evaluating out this total shear moment diagram results. Okay, which will be ready. Yes, they are now ready. Just for a minute. Yes, this is my SFD and BMD diagram, okay, that we are getting out for this simply supported beam with point load. Okay, I'll just go in the details for the shear moment diagram. Here I'll be just plotting out this directional shear moment diagram where you will be getting out the SFD and BMD. So I'll be just right clicking on this directional shear moment diagram. I'll be evaluating all the results here. Once I do out that, yes, you get out this particular SFD and BMD. You can just check out where the uh, total that you are observing out, okay, the red line indicates out the shear moment, shear force, and the green line indicates out the bending moment, whereas the blue line indicates out the displacement. Okay, you can just check out it is minimum at minus 4000, it is, that is minus 4000 newton at 0 mm, and at 2500 mm the maximum shear force, it is 4000 newton that you are getting out. Again, if you just go ahead with the bending moment in newton per mm, okay, it is minimum at 0 mm, that in which we are getting out 5 into 10 raised to e raised to 0.006 newton mm, whereas at the center, that is at a distance of 2500 mm, it is maximum. Okay, again you can just check out the displacement in mm. Okay, it is minimum at 2500 mm where we are applying out a point load. Okay, so we'll be getting out a displacement in mm. So this is the shear force and bending moment diagram for this simply supported beam with point load of 8 kilonewton, which is acting at the center, that is at 2.5 meter. So by Ansys Workbench, we can also plot out this SFD and BMD for your cantilever or your simply supported beam problems. Okay, so this was the problem for as well as for the second experiment where we our aim is to study out the stress deformation in the simply supported beam, and in the part of the third experiment, that is to plot out the shear force diagram and the bending moment diagram. Okay, in the case of this simply supported beam. So this covers out your experiment number 3, that is study of SFD and BMD for your simply supported beam with point load at center. Thank you.